morning, boys and girls. I wanted to make this video just to kind of refresh your memories regarding fractions, um, and more particular in adding, subtracting, and comparing fractions. First off, I want to talk about the fraction itself. We have our numerator on the top, and our denominator on the bottom. Okay? The denominators, when we're adding and subtracting fractions, which is our bottom number, must be the same. Remember, we talked about that. All fractions, when we're adding, subtracting, or comparing them, the denominators must be the same because the denominator represents the pieces. So if I have a fraction that shows me 3/4, it's going to look like this. The 3, which is my numerator, represents how many pieces I have, and the 4 represents out of how many total pieces I would have, or what it's cut into. So in this instance, my numerator would be 3 because I have 3 pieces out of the total 4 that the pie or pizza is cut into. So let's remember that. What a fraction is, they're parts of a whole. Anytime you have a fraction, that's a proper fraction, it represents less than 1 or part of a whole. Okay, so in this case, I have 3 pieces out of a full whole pie, which has 4 pieces in it. I've only got 3. Key is I can't add, subtract, or compare fractions unless those number of pieces are the same. Meaning, if I had a pie that looked like this, and it was only cut into halves, I cannot take one of those pieces. Okay, let's say I have 1/2. Everybody should know that that is 1/2. I cannot add 3/4 and 1/2 because I can't put that piece there. He's not the same size. Okay, he's not the same size, nor is he really the same shape. Let's, for this, say that these 2 pies are exactly the same size, but my pieces are not the same size. So in order for me to add them, I have to get him to look like him. I have to have him cut in the same number of pieces as he is. That's why the denominators must be the same. I'm getting this denominator to be him so that I can add them together. Now, when I do that, as you guys know, we're going to create an equivalent fraction for him. I can get him to be 4, and I do that through multiplication. And remember, when we create equivalent fractions, we're always multiplying that fraction by 1. And 2/2 is 1 whole. And anytime you multiply a number by 1, you get the same number. But in this instance, when we're dealing with fractions, when we multiply a fraction by 1 in this manner, we get different digits. That's okay. I can have different digits. Just he is still equal to him. And here's why. When I'm creating equivalent fractions in order so that I can have the same denominator as another fraction, this is really what I'm doing. When I multiply him by 1, I'm really taking this original piece and I'm cutting it again to match him. So you could see how my original 1/2 is now 2/4. There's my 2 pieces out of my 4 now. So when I create an equivalent fraction, so that I can use that to have common denominators, I'm really taking one of my fractions and cutting more pieces in it to match what I need to add it to. And that's what we did in this one. Now, whether it's fraction plus fraction or whether it's mixed number plus mixed number, remember a mixed number is a whole number combined with a fraction. That looks like, for instance, 3 1/4. That is a mixed number. That is a proper fraction, and a fraction where my numerator is larger than my denominator is an improper fraction. You should remember all those things. Just trying to give you some things to jog your memory. But remember this is always the key. When you're adding and subtracting fractions, the denominators must be the same or you cannot do it. You also cannot and never will add across my denominators. Because the denominator only tells you how many pieces are available or what the pie is cut into. The numerators on the top are what tell you how many pieces you have. And if you want to combine them together, like in this case, I could combine those together and I'd have a mixed number. I put him there, I'd make me one whole pie and I'd have one left over. So just remember that we are talking about the golden rule. You cannot add, subtract, or compare fractions unless the denominators are the same. So one more quick example. If I told you and I wanted you to compare 3/4, okay, compare it to 7/8. You cannot do that right here. We're not cross multiplying. We're not doing any of that. We are finding common denominators. And in this instance, regardless of whether I'm comparing it, whether I'm adding them, or whether I'm subtracting them, doesn't matter. The denominators must become the same. So in this instance, let's just, for this case, say we're going to compare them using greater than, less than, or equal to. I can get him to become 8, right? So we're going to get and create an equivalent fraction so that my number of pieces are the same. So in order for me to get him to 8, I would have to multiply him by 2/2, which is 1. Anytime you multiply a number by 1, you get that same number. But in this case, we're cutting the pizza up and we're going to have different digits. 3 times 2 is 6. 2 times 4 is 8. This guy right here is equivalent or the same as him. So I'm going to, remember I used the term substitute. He's going to go in for him. So now my new problem that I'm looking at is I'm comparing his substitute, which is 6/8, with 7/8. And obviously we can see that 7/8 is greater than 6/8. But the work that has to be done first is getting those denominators the same. So I hope that helped, and I will continue down with other videos regarding the things that we learned for fractions.